Welcome back. When I talked about data types in one of the first videos, I went over the basic types used for integers, floats, and strings, and I also covered booleans. But when I started talking about classes, I didn't mention that at all. There is a little bit more to that than just what data type the classes are, because inheritance can make things a little tricky to understand. Let's start off by creating a new class. We'll make our enemy class again. So here's a little enemy. If I go to PlayState and I create a new variable called enemy and create a new enemy instance, that will run just fine. Now, the data type of enemy is the name of the class. So enemy. That's pretty straightforward. If I run that, it compiles just fine. But where this topic can get a little bit hairy is with inheritance. So I'm going to make another class. I'll make the dragon class again. And we'll extends enemy. Now with the dragon, I also want to add a function, which is public, and we'll call this raw, I guess. So here's our dragon. It extends enemy and has a raw function. If I create the dragon, I can give it the data type dragon and create a new dragon. And then I could just call dragon raw on it. This works out as you might expect. Now where things get a bit interesting is you can actually create an instance of dragon over an enemy type and it will actually compile. This works just fine. Now the reason for this is that the dragon is actually an enemy. The enemy class is the superclass of dragon, or in other words, dragon inherits from enemy. Another way to say this is that dragon is a type of enemy. So because that is true, anything that is a type of enemy, anything that subclasses enemy, can also be constructed here. This is very useful when you're creating arrays. If you have an enemy class that then has a billion subclasses for dragon and goblin and knight and whatever, if you create an array of enemies, all of those enemy types can also be placed into this array. And you'll also see a class in HaxeFlixel itself called an FLX group, which does this exact thing. It takes in a type of FLX basic, which means you can put any FLX sprite in there if you want. But the problem with this is that Haxe can only see this enemy type. It sees a variable of type enemy. So if you try to do enemy.raw, you get an error. Because raw does not exist on enemy, it only exists on dragon. And this makes sense. If you made a subclass of enemy called goblin, a goblin wouldn't be able to raw. So if you made an enemy type and then replaced the dragon with a goblin instead, this line of code would make no sense. Unless the goblin could also raw for some reason. But in some cases you do want to call this raw method. So how would you fix that? You fix that with something called casting. To cast a type to another type, you create a new variable. I'm going to call this dragon, and we'll give it the correct type of dragon. In order to convert this enemy to a dragon, we need to use cast. Now you could just type in cast enemy, and that would be enough. As long as you define the type of class here on the variable, then cast enemy will work fine. Otherwise, you can also get rid of the type, use type inference, and then turn this cast into a function that converts to dragon. That will also work. So there's two ways to do casting, but the end result in both cases is a dragon type, which can now raw without compiler errors. Now, even though you don't get compile errors, you can get runtime errors. If I create another variable, let's just use FLX state. If I try to convert that into a dragon, that makes no sense, but it will still compile. But if you try to run the code, you get an error. It says uncaught exception, class cast error. And it also points out where the cast is being done, which is line 14. The reason I say that this is a runtime error instead of a compile error is because this error can happen at any point while your program is running. A compile error can only happen when your code compiles, but before the game actually runs. So if you wanted to avoid this error, you would have to validate in some way that the thing that you are casting is indeed the type that you ask for. Haxe has a built-in way of doing this called std.isOfType. And here we can type thing and ask if the thing is of type dragon. Put everything in that if statement there. And I'll do an else statement and trace not a dragon. So it prints not a dragon, and it doesn't cause any errors because this code here isn't being run. The best practice would be to structure your code so that you don't end up in a situation where you need to cast. But in some cases you do have to use this, and this is an effective way of checking the type of a variable before you try to cast it. And that's about it. Because this is a bonus video, I won't do a challenge. I'll just leave it at that.